this session is called Happy Little Accidents, Lessons from 3 Games and 2 Mud versions. So here's the first happy little accident, the happy little accident being technical difficulties as we try to do this hybrid. But the title is pretty self-explanatory. It's going to be a fireside chat with myself, Alvarius, and Kooshaba, who you guys have met already. They've worked on 3 onchain games and 2 versions of Mud in the last few years. And we'll go through some little happy little accidents and lessons that we've learned along the way that we think will be relevant to many of you here who's interested in or currently building onchain games. So before we start, quick intros. I'm Biscaryn. I've been at Lattice since almost the beginning, doing strategy and ops. So which means at a startup, basically doing everything. I've seen all of these games that we're going to talk about up close and have helped create them in some form in different capacities. So that includes random stuff like sound and music, and also launch and marketing and partnerships and things like that. So Alvarius, do you want to quickly intro yourself as well?
Sure, yeah. Okay, so my name is Alvarius. I started Lattice almost 3 years ago together with Justin. And yeah, I was around for 3 games and 2 Mud versions, and all of them had a lot of accidents that we're going to tell us about here.
Yep, and I'm Kooshaba. They brought me on to make the games. I was the game guy.
Alrighty, so let's dive into it. I want to start with something called ZK Dungeon, who many of you might not have heard of. It's an unreleased game that we developed over at Lattice all the way summer 2021. So let me set the scene a little bit. So it's the summer of 2021. This was around the time Dark Forest was being worked on by Gupsheep and co, including Kooshaba. And the first rounds were about to begin. The state of the art at the point in writing Ethereum apps was the Diamond standard, which allowed you to go over the smart contract size limit, get contracts upgradability, and also organize your code a little bit. With that background, Alvarius, maybe you could give us a little bit of what ZK Dungeon was.
I didn't fully understand the question, but I think you're asking what the background was and how we got started. So I'll just tell you about that. So the original, so we basically got inspired by Dark Forest, which is a game that Kooshaba was working on. And we thought it was really interesting that there's this global computer that you can just deploy things to. And unlike in other games where when you mod the game, you basically kind of create a fork of the game. Like when you mod a Minecraft server, you then have 2 different Minecraft servers and they have maybe different functionalities, but it's 2 different worlds. What we found really interesting here is that this global computer actually allows you to deploy stuff to it, and then you can mod a game while still being the same universe. So you can have these kind of like alternative realities, but in the same world, or just deploy new functionality into an existing world. That really fascinated us in the beginning, and so we and also still fascinates us today. And that's how we got started with ZK Dungeon. The game mechanics were on an abstract level really similar to Dark Forest. Maybe do you want to give a super quick TLDR on Dark Forest game mechanics?
Yeah. Dark Forest was a MMO RTS. Like thousands of players would be in one persistent universe. You'd start on a planet, and the goal was to capture other planets in real time. It was real time, but the action times were pretty long. Like by the end of a round, which would last up to 10 days, your voyage from planet to planet could take like 3, 4, 5, 6 hours. So it's a very long burn of a game.
Yeah, and so we actually started with the same code base, and we used some of the same mechanics in the beginning, where every coordinate is not stored as an actual clear text coordinate, but basically hashed, and then we just store the hash of the coordinate on chain. And so in order to know what is where, you have to first basically brute force mine the entire map to then find out what is where. And while that made a lot of sense in Dark Forest, where it's basically a very sparse coordinate system and you have to actually like put in some time to then find planets, in our game it turned out it doesn't make that much sense because we have a very dense grid. So maybe it's super quick overview over the game itself. It was kind of like Dungeon Keeper. So you have this dungeon, you start with a base and then you mine. You increase the size of your base by mining, you find resources, and then with those resources you can spawn creatures, and then with those creatures you can attack other players' bases. Oh, do we have footage? Amazing. Yeah, so this is basically how it looked like. And yeah, in the beginning, we used the same mechanics. Everything was hashed. You had to first mine the map. But then because it was this dense grid instead of a sparse grid, it actually only took like a couple minutes to mine the entire map. And so we decided to get rid of the hashing and the ZK mechanics there and just make everything clear text. But the name ZK Dungeon still stuck around for a little bit longer because we couldn't find a better name. And then at some point, we renamed it to Ember.
So not only was the ZK part of the game not making the cut, the actual game itself also didn't get released in the end. So, Alvarius, do you want to tell us a little bit what were maybe the reasons behind that?
Yeah, so we worked on this game for around 5 months until we had until we really play tested for the first time. We had never really developed the game before, so nobody told us that you're supposed to play test your game. We just thought we have a really good idea and we thought it's for sure going to be fun. But then we just implemented the entire thing. It took us a really long time because there was no framework or anything like that at the time. And so we just implemented everything from scratch, and the entire networking code and everything was basically tailor-made for this specific game. And then we started playtesting after those 5 months and realized that it's way less fun than we thought it is. And then we wanted to start iterating on the game and like make it fun by changing the game mechanics. But because the entire network stack and everything was tailor-made to the specific game mechanics that we had in mind, iterating on the game mechanics was almost impossible. Like we tried it for a bit, but then we just introduced a bunch of bugs while having to change the entire network code every time any of the game mechanics changed. And so, yeah, we then at some point at the end of this year, I think this was 2021, at the end of that year, we basically decided to re-architect the game, like essentially start from scratch with a better architecture, a more general architecture for the network stack specifically, and then rebuild the game on top of that. But we then decided not to, and instead start with a different game. That's around when Kooshaba joined as well.
Okay, so to summarize a little bit, there's like two main happy little accidents and learnings there. I mean, one was the fact that we didn't iterate quickly and we didn't iterate at all. Didn't play test it early. And two was probably the architecture problem that you mentioned there, where the architecture made it very difficult to iterate in the first place. So I guess that brings us to the next step in the journey, which for us was this thing, ECS exploration, entity component system. Alvarius, do you want to talk us through how you land at ECS, ZK Dungeon?
Yeah, so as I said before, we never had really developed a game before that. And so we also didn't know about the patterns that people used for developing games. We just approached it with what we knew before from traditional development, like traditional application development. And then when we did that re-architecture, we first did some research into, okay, how do people actually build games? And so we found ECS, which is a very popular pattern in game development. ECS stands for Entity Component System. And so essentially, before what we did was have different classes, each of the classes, like the different things in the game, each of the things in the game was a different class. And then we had to implement the functionality for each of the things in the game specifically for that thing in the game. So if you had two things that could move, you might have had two classes, like let's say an imp and like a monster. Both of them were supposed to be able to move, but then we implemented the move logic in each of those classes before that. And that just didn't scale very well, and it was kind of hard to, it got really messy really quickly. And so we discovered ECS, and with ECS, like it seems very attractive to developers at the beginning at least, because it seems like you can have almost infinite complexity while still keeping your code very, very clean and organized. Because what happens is you just have these components, which is kind of like properties that you can attach to entities, and then you implement your systems based on the components. So as an example, with our movable example, you can have a movable component that you can attach to any entity, for example, to the imp entity and to the monster entity. And then you implement a move system, which doesn't care about what type of entity that is and just cares about whether it has the movable component or not. And so we discovered that. We thought it's a really neat pattern, and thought it would make it much easier to implement all the complexity that we wanted in our games. And so we decided to put that on chain. And nobody really had put ECS on chain before that, and so it was a bit of a gamble. But yeah, it turned out that it worked surprisingly well. And so that turned out then to MUD v1 in the end.
How was that implemented on chain? How did it look like in terms of the contracts?
Essentially, each component was its own contract. So we thought of how to implement ECS on chain, and again, didn't exist before. So we had to think about how we could possibly implement that. What we came up with in the first version of MUD was a separate contract for each component, because each component is supposed to store separate types of data. And then each system also is a component, and each system just accesses calls the contracts that you need to call. And then there's a central registry, which we call the world contract. And essentially, whenever a system wants to read or write from a component, it first has to ask the central world contract for the address of that component, and then can read and write from that. That was like the very high level architecture. Yeah.
I see. And that basically was MUD 1 in a nutshell. One thing that came after MUD 1 in the summer of 2022, right after we developed the first version, was Skystrife. It wasn't called Skystrife back then. It was called MUD War. And if people have seen Skystrife today, it might look a little bit different from this version of Skystrife in the beginning. Kooshaba was the one who actually developed the first versions of MUD War. Do you want to maybe talk us through how did it feel coming from working on Dark Forest to working on MUD War?
Yes, I will talk about that. So basically, early 2022, I was slowly losing my mind working on Dark Forest because it was a giant monolithic code base, and every single feature would take me 6 weeks and like a 40,000 line PR to implement. So I was pretty done doing that, but I was chugging along, and I got a call from I got a call from Justin. It was like, hey, I have a game engine, and I was ready. I was like, yeah, sign me up, man. Please get me out of here. They came to New York, where I was living at the time, and within 2 weeks of like seeing MUD 1, we had our first play test on MUD War, and I was just blown away. And it was already like nearing the complexity of Dark Forest in those 2 weeks, and we had 16 players get in, actually play, and give us feedback right away. So I was hooked right off the bat. In terms of productivity, it was a quantum leap.
Yeah, and you told me actually before that it might have been so quick to develop that we basically ballooned in terms of features very quickly. You want to talk about that a little bit?
Yeah, I mean, I think this is the nature of things. We felt the power, and we were like, let's just add all of our wildest dreams to this game. So it just got bigger and bigger and bigger, and so many systems. And then, as Raph said, the final version of Skystrife was actually just the process of subtracting things from those systems. We had this massive statue that we'd created, and we were just chipping away at it, chipping away at the granite. But the version in the video here is a version of Skystrife where I believe, this is a 16-player match taking place across 5 different islands, portals everywhere, 9 different types of units. It was a pretty mind-bending experience for players. It was very, very difficult to play, and your heart rate would be 150 beats per minute for an hour straight. I enjoyed it. It was a special type of gaming experience, but we quickly realized this was not manageable. But once again, MUD was very malleable. We had separated all of this complexity into its separate systems. So the subtractive process of coming down to where we're at today was actually very nice. We didn't have to destroy the game to iterate quickly.
I can attest to this version of Skystrife being extremely difficult to play. You had to teleport around the islands and keep track of 2-3 different armies. But at the same time, when we were working on this version of Skystrife, we're actually starting a different project that started off as a little hackathon projects. So OP Crafts, also called Mudcraft at the time. Alvarius, do you want to tell us how did it actually come to be? Why did we start working on Mudcraft/OP Crafts?
Yeah, so during that residency in New York that Xerox PARC organized, the Lattice team was there, but there was also a bunch of other teams in the Xerox PARC ecosystem there. And so at some point there was this 1 week long hackathon that Xerox PARC organized, and we as the Mud team we had a workshop planned for Wednesday of that week where we wanted to show people how to use Mud, like the basics of Mud, similar to the workshop we gave yesterday. In order to inspire people to maybe build stuff with Mud at the hackathon. And then the last slide of that hackathon, of that workshop, was basically as a joke, all right, now with that new knowledge that you have, build on-chain Minecraft. And then that was Wednesday, and then Wednesday evening, we were basically like, what would it actually take to build Minecraft on-chain? Because if you think about the basic physics of Minecraft, it's pretty simple. And it works really well on a transaction-based system like a blockchain, because every block that you can place or mine or craft, all of that can be a transaction. And so basically for the remaining 2 days of that hackathon, we basically made it a challenge for ourselves to see if we can actually implement on-chain Minecraft. And it worked. We had our first prototype in 2 days, and then it took another 3 months to polish it and make it an actual ready product. But in 2 days, we already had the first version. So there was basically the best hackathon of my life, I think.
Yeah, and here's a video of OP Craft for those of you who haven't seen it in action. What were there any happy accidents or learnings, Alvarius, would you say?
Yeah, so we had this on-chain Minecraft, but we were pretty much ECS maxis at that time. And so the way we implemented this, which made it very easy to implement this, was every block in this game is a unique entity. And then each of these block entities has a position component attached to it and a terrain type component attached to it. And when you mine it, you just remove the position component and you add an owned by component, and then that puts it in the inventory of the player. That again made it super easy to implement. Feels great when you just have to implement 2 systems and 3 components and suddenly you have Minecraft. But the problem with that is that we ran into state bloat issues really quickly, because people started mining blocks and they were placed in the inventories. And then after 2 weeks of playtest, we already had like 10 million block entities, and we didn't have partial loading at the time. So the client basically had to load 10 million unique block entities into from the contracts every time you loaded up the game. One interesting thing with that is that each block actually had a unique, you could basically see the unique history of each block. Like each dirt block was kind of non-fungible. But in terms of architecture, that made it really, really hard to scale. And it was also kind of a limitation of the pure ECS approach where, it would be easy to implement, or it is now easy to implement an inventory if you have basically the power of tables, and you can basically just store player, block type, and the number of blocks of this type in the inventory. But back then we didn't have that, and so we had to store each block as an individual entity. And then besides that, Mud1 also had a lot of inefficiencies in how the data was encoded. So it was a lot of data, and then also it was a lot of entities, and each of the entities was also, in addition to that, inefficiently encoded, and so it was even more state bloat at the end.
I guess one side note is one of the reasons that we had this state bloat is it's Kooshaba, actually, one of the contributors to this state bloat. Kooshaba didn't work on OP Craft, so we're still working on Skystripe at that time. And can you tell us a little bit, what did you do?
Yeah, so I took a break from Skystripe development to just play OP Craft, and I was like, okay, let's see how fast I can break it. And I found out infinite diamond mining within the day. So there was, I don't know if you can see in this screenshot, but every time someone mined something in OP Craft, it would show what got mined on top. It's like a nice little ticker of the whole world. And suddenly the entire thing was just filled with diamonds, and quickly other people figured out what I was doing. So it was just a diamond race throughout the world. By the end, it was just like MEV front running each other, trying to grab all the diamonds and to see who could take over the world. It got very fun.
Yeah. Okay. So summarizing the learnings from OpenCraft, it was the fact that there was the data modeling problem of adhering too much to the ECS standard, and then the second one being the fact that we couldn't have a way to efficiently basically parse up state, like load the state partially, and we had to just show everything that happened in the world, which meant that everyone had to spend 10-20 minutes loading the game at the beginning. But that brings us to our next step, actually. Alvarius, how did that experience go from OPCraft to Mod 2, actually?
Yeah, so basically with OPCraft, we ran into all the limitations with ECS, with the data model we used, and also the encoding. And so early 2023, so this year, we thought about how to fix that. We thought if we can fix it in Mod 1, but we realized actually it needs some more fundamental changes. And so we changed the data model. We realized that ECS is essentially a kind of a subset of relational databases where you're limited to one primary key. But if you have the full power of relational databases, you can still use ECS if you want to, but you can also model things in a more efficient way if it's necessary for the specific use case. And so we started thinking of how we could implement that. And we also thought it would take us 2 months and would be a very easy upgrade for everybody who uses Mod 1. Turns out it almost took us a year now, and it's a very painful upgrade. But once you're on Mod 2, everything's great. And we're also pretty happy with the new version, and it's hopefully not gonna change anytime soon.
I had a very fun full code base conversion from Mod 1 to Mod 2, but at least I went through all that pain first, so the other developers had a little bit of a guide when they had to do it.
And not only that, right, Kooshaba, apart from the upgrade, Skystripe has actually informed parts of Mod 2 as well. Kind of, would you like to maybe tell us how Skystripe has kind of informed features in Mod 2?
Yeah. So first I'll just say that Mod 2 cut our gas use by, I don't know, 80%, I would say, to the point where now on Redstone playing a Skystripe match is less than 50 cents, maybe even I think less than that, less than 20 cents. So that was just incredible. So I was very, very happy with it, even though I went through the pain of converting. One thing that Skystripe tried to pioneer was this concept of session-based matches, where similar to a traditional RTS game, you'd play a 4-player match. That's all you care about. You compete against the 3 other players, and then after the match is over, you throw it away. You take something out of it, you take the rewards out of it, you take the record out of it. But after that, it doesn't really matter that state exists for your client. So Skystripe really had this requirement of segmenting the state that was sent from our custom indexer. And then also, even when you're loading from RPC, we needed to ignore certain parts of state. Let's say there's 10 matches going on. I don't care about the 9 other matches. I just care about the match that I'm in. So we developed a system where you can define a specific key schema on the MUD contracts. As long as you adhere to that simple system, both your client and our custom indexer just kind of knows how to segment the state for you, and the developers can just move on without having these massive state bloat issues that we saw in OPCraft.
Alrighty. And that brings us to today, wrapping up a little bit. We have experienced many happy little accidents and learning throughout the way, and we probably will also going forward. Just to summarize for us a little bit the lessons that we have learned. Very quickly, it was to iterate early and iterate quickly. 2, to use an architecture framework that allows you to quickly and easily iterate. 3, don't overcomplicate the game with digital physics. Focus on refining a simple core and let the rest emerge. 4, from OPCraft, which was easy, this is great, but don't overdo it. Other data models might work better and more efficiently. And finally, from OPCraft and Skystripe, is to think about your networking and indexing with partial state loading in mind. And that wraps up the lesson we've learned up to this point. Thank you, both of you, for being here. The question we have for the post-assembly is, when developing an on-chain game or an AW, what are some good mistakes to run into? and what are some mistakes that you should avoid at all costs. And with that wraps up this little chat. Thank you, everybody.